Okay, so we're going to be solving multiple triangles. So the value I want is x. It's all the way over here in this triangle. So I need to start all the way back in this triangle and work my way through them to get to the value of x. So the first thing I want to do is I want to look at the triangle way back here. So if I look at this triangle, it's not a right triangle, so I can use sine law or cosine law. I have an angle contained within two sides, which means I'm going to use the cosine law. So what I want to do is maybe label the sides. I'm going to label this one B, C, and A. So then what I can use the cosine law. So I can say that A squared is equal to B squared plus C squared minus 2BC cos A. Then what I can do is I can plug the values in. So I'm looking for A squared in this case. My B is 13.5, C is 4.3, minus 2, 13.5, 4.3, cos of 20. So now what I want to do is I want to be able to take the square root of all of that. So I'm going to put all of that in my calculator. So I have 13.5 squared plus 4.3 squared minus 2 times 13.5 times 4.3, and then I have cos of 20 degrees, and I'm going to hit equals. And I'm going to write down every last decimal place. You do not round in the middle of a question. So I'm going to write down 91.64168673. And then I can take the square root of that answer. So I get 9.57. So I can round at the end of this section. And I have 9.57 centimeters. So I found the value of A. So now I have something in this new triangle as I move forward. This triangle is a right angle triangle. This is the side that is shared by the other two triangles. So that's the side I'm looking for. That would be the hypotenuse, or H, of this triangle. This is the adjacent side of 22. So it means I'm going to use the cosine ratio. So now I have cos of 22 degrees. My adjacent side is the side I previously found, and I'm looking for the hypotenuse. Now I can say that the hypotenuse is 9.57 divided by cos 22. So I'm going to plug in 9.57, and I'm going to divide that by cos of 22. And I'm left with 10.32. And that is also centimeters. Now I'm going to move into the last triangle, which is the one I was looking for the value of x. Again, not a right triangle, but I can see that I have this opposite this, and now I have this opposite the side I found. That means I can use the sine law, because again, it's not a right triangle, and I have a side opposite an angle that I know. So I can say that sine A over A is equal to sine B over B. So sine of x is opposite the side I found. And this is sine of 62, opposite side 10. So I can isolate for x, so that's sine inverse. I'm going to bring the 10.32 up. Sine 62 over 10. Then what I can do is I can actually put all of that into my calculator again at once. So I'm going to take my calculator. I'm going to say, well, this is sine inverse. I'm going to put a bracket. And then I'm going to do 10.32 sine of 62. And I'm going to divide that by 10. And then I'm going to close my bracket. And I can hit equals. And I get 65.67 degrees, because in this last case I'm looking for an angle. So I have 65.67 degrees. And that's my value of x. Okay, next I want to look at and remind myself what is an angle of elevation and what is an angle of depression. So if I draw the ground, and I'm going to draw the ground for the angle of depression as well. And I'm going to draw a lovely person standing on the ground. And I'm going to draw another lovely person standing on the ground. So the angle of elevation means that when I have my sight line, so we're looking straight out, this is the horizontal. Same thing with the angle of depression, we're still going to look straight out. Okay, so that is the line of sight. The horizontal, it's the line of sight. Okay, so angle of elevation is when we look up. So we look from the line of sight, and then we look up. This inside is the angle of elevation. The angle of depression is when we look down. So we start at the line of sight, and we look down. So this angle here, between the line of sight and looking down, is the angle of depression. So the angle of elevation is from the line of sight looking up, and the angle of depression is from the line of sight looking down. Okay, so if we look at the next question, we're going to look at Mildred. So she looks out of her window at the building 15 meters across the street. The angle of elevation to the roof is 15 degrees, and the angle of depression to the bottom is 50. How tall is the building? So if I look, there's one building, and this building needs to be bigger. So here is Mildred right here. Her line of sight goes like this. She can look up, and she can look down. Looking up is 15 degrees, looking down is 50 degrees. The distance between the buildings was 15 meters. So from here to here, and from here to here, I can find. So if I look, I'll call this X, and I'll call this Y. So to find the value of X, I'm going to use the tan ratio. So it's opposite over adjacent. So I can say that tan of 50 degrees, opposite that is X, Adjacent is this, which is the same as that. And I can solve for x. So I'm going to take my calculator and I'm going to say 15 tan 50, and I get 17.88. So I get 17.88, and that's equal to x. I need to do y now. I'm going to do exactly the same thing to find y in this case. So I have tan of 15, opposite 15 is y, adjacent is also 15 because it's this side length as well. So I can say 15 tan 15 is equal to y. Again, I'm going to pull out the calculator. I'm going to do 15 tan 15, and I get 4.02. But I want the whole height of the building, so I'm going to add the two values together. And when I add the two of them together, I get 21.90 meters. And now I can write my concluding sentence. So I can say, therefore, the building is 21.90 meters.